Hey everyone, welcome back. In our last video, we learned how to design the base here for our signer award, this black piece. Well, in this video, we're going to learn how to manufacture the base here out of a block of plastic. All right, so when you're ready, go ahead and open up your file that you made in the last video, okay? And once you have it open, click on your design here and come on down now to manufacture. All right, so the first thing we want to do now is go ahead now and flip our part over so that the hollowed out portion is visible. All right, and we're going to go ahead now and start a new setup. Now we need to set up our work coordinate system. In other words, we need to specify which way X, Y, and Z are pointing. And it's very important you do this correctly, because if you don't, it can lead to a machine crash or other types of accidents. Okay, so it's customary in milling and machining to select the back left corner. So I'm going to go ahead now and just select that corner. Okay, and I'm going to kind of rotate it here. So imagine now your part is in the machine, in the vise in front of you. When you have your work coordinate system set up properly, you need to make sure that your positive X is pointing to the right, your positive Y is pointing away from you, and your positive Z is pointing up. If it doesn't look like this, okay, come on over here and go to select your X-axis. Now, what you can do is you can specify, pick a line or a feature on here that's pointing in the X-axis. You can click here, and this line here is pointing in the X direction, so you can click that, okay? And then you can flip the X-axis, okay, by checking this box or unchecking it, okay? So once you have your work coordinate system looking like this, okay, you're good to go. All right, now we can set up our stock material size. Now we're going to manufacture this out of a block of plastic. So let's go over here to stock. We need to specify how big our block is here. So we're going to come over to mode and we're going to select fixed size box. All right, remember our part here has a total diameter of 3 inches. So our stock size needs to be slightly wider or larger. So our width here, we're going to set that to 3.25 inches, and we're going to make sure the model position here is centered. Our depth, same thing, 3.25 inches, it's centered, but our thickness here, we want it to be 1 inch because our block of plastic is 1 inch in height, okay? But we don't want it centered. We want it offset from positive Z, okay? And we want that distance to be offset 0.02 inches. So if we click on the bottom here and we zoom in, it's 0.02 inches offset from the very top of our stock material. So this little distance right here represents 0.02 inches. And we're going to remove that material in our first operation. Okay, so I'm going to go ahead now and hit OK. Our setup, when you're all done, hopefully looks something like this. All right, so I'm going to go ahead real quick and just change this to setup 1. All right, and now we're going to start our first operation. And when you're milling or machining, you traditionally start off with a facing operation. So I'm going to come up to 2D. I'm going to select a facing operation. Okay, I'm going to go ahead now and in our tool library, our Sign Award tool library, hopefully you got it uploaded and installed. From our Sign Award tool library, we're going to select our 2.5 inch face mill. So let's go ahead and select that guy. All right, and since we're machining this out of plastic, we're going to set our coolant now to disabled. Okay, and we're going to do this for every operation except for our pocket. All right, and I'll explain later. So for our feeds and speeds, for this whole video, we're going to be using some very aggressive feeds and speeds because the material is plastic and we can cut through it much faster. So for our spindle speed, we're going to set that guy to 4,000, and for our cutting feed rate, 40 inches per minute. Now for our geometry, I'm simply going to select this outer perimeter, okay, of our part, and then for our passes tab, we're going to set our pass extension, okay, to 0.75 inches. This will tell our tool to go out 0.75 inches past the edges of the part, our stock material, and then our stock offset. This will widen our tool path, so we're going to widen it 1/4 inch or 0.25 inches, okay. Everything else looks good. Let's go ahead and select OK, and you should get the following tool path. All right, so now we want to remove the material around the exterior of our part here. So we're going to come on up to 2D adaptive clearing, and we're going to use a 2D adaptive clearing operation to do that. So we need to change our tool though now. So come on over to our Sign Award tool library, and we got to select our 3/8 end mill here. Now it's very important to note that this is a 2 flute 3/8 end mill. Okay, if you're using a 3 or 4 flute end mill, it would literally melt the plastic as it's machining or milling it due to friction. Okay, so it's important to use a 2 flute 3/8 end mill. So I'm going to go ahead and select that guy. Make sure my coolant here is disabled. Since this is a roughing operation, we're going to speed things up a bit. We're going to set our spindle speed here to 5,000 and our cutting feed rate here to 40 inches per minute. So we're going to be going pretty fast. And in fact, we could probably even go faster, because if you use a chip load and you calculate your feed and speed for your feed rate and you use a chip load for soft plastics, you get around 100 inches per minute. But we're not going to go that fast. Okay, we're going to keep our feeds and speeds a little bit more conservatively just to prevent accidents. Okay. All right, now for our geometry, we're just going to select here, all right, the outer edge of this part, right? Well, let me move it around here so you can see a little bit better. This guy right here, okay? And then for our heights tab, okay, now it's going to cut down to that line we selected. We want to move it down, so we're going to come to we want to come down to just model bottom, okay, and we can offset it 0. So now the tool will come down to, instead of this line, it'll come down to the bottom, okay. All right, and now let's come on over to our passes tab, and we're going to set our optimal load or step over up to 0.2. Now that's a large step over. We wouldn't normally be doing that with metal, but once again, this is plastic, it's softer, we can get away with a larger step over. And remember, step over is basically the percentage of tool engagement with your part material. Okay, so for stock to leave, make sure your stock to leave box is checked, and we want to leave behind 0.02 inches of radial stock along the floors and 0.02 inches of axial stock along the walls. Okay, remember, this is a roughing operation, so it's you always want to leave behind some material. Okay. All right, once you have those values entered, go ahead and select OK. Okay, and when you're done, you should hopefully get a tool path that looks something like that. All right, so now let's go ahead and select our third operation here. We're going to come on up to 3D now, and we're going to select 3D pocket clearing. All right. We're going to keep our same tool that we used last time, our 3/8 2 flute end mill. However, this time we are going to set our coolant to flood. This way we flush out all of the chips that accumulate in the pocket here. We're going to use a spindle speed of 5,000. We're going to use a cutting feed rate once again of 40 inches per minute. So also your ramp spindle speed, let's go ahead and select 5,000 RPMs, and let's set our ramp and plunge feed rates to 15 inches per minute here. Okay, now for our geometry now, we're just going to select this line right here. And for our heights tab now, we're going to set our retract height to model top, and we're going to offset it 0.3 inches. Okay. And then for our passes tab, we're going to check manual step over, and we're going to use a maximum step over here of 0.2 inches and a minimum step over of 0.2 inches as well. Okay. Now for stock to leave, okay, we're not going to leave any stock behind. This is a roughing operation, but since we don't really require a degree of accuracy along the floor here, we're going to set our radial stock to leave to 0. Okay, our axial along the walls, yes, we are going to leave 0.02. Okay, so we're going to leave 0.02 inches along of stock along the walls of our container, and we're going to leave nothing along the floors on the inside of our container. Okay. And before I forget, this is very important, set your maximum roughing step down to 0.2, not 0.04, but 0.2. Okay, this literally means the difference between this operation taking a minute or two to taking 5 or 6 minutes. Okay, so yes, make sure you set your maximum roughing step down to 0.2. All right, and come on down now and check smoothing. This will simplify some of our G code. And then finally, let's come on over to the linking tab and set your ramp type. Make sure it's helix, and we're going to set it as 4 degrees. Okay. Once that's done, go ahead and select OK, and you should end up with the following toolpath. And please make sure you simulate every single toolpath when you're done. Okay, just to be careful and to be safe. Okay, and also because when you know the toolpaths, okay, it helps you when you go to run the machine because you'll better understand what the machine is doing as you watch it. All right, now our roughing operations are done. Now we got to go around with our tool and clean things up with our finishing operations. Okay, so now let's go on up here to 2D and we're going to do a 2D contour. Okay, we're going to use the same tool, 3/8 flat end mill. Our coolant now is going to be disabled. All right, and remember with finishing passes, we slow things down a bit. Okay, this will give us a more accurate high tolerance part. So we're going to do our spindle speed of 3,000 and a cutting feed rate now of 20 inches per minute. Okay, we're going to come on over to geometry now, and we want to remove the material along the outside of our part here. Okay, because if you remember, we left some material behind. So I'm just going to click that guy, and now we're going to come on over to our heights, and we're going to set our bottom height to our model bottom. Okay, now we're going to come on over to our passes tab. We're just going to check smoothing and we're going to select OK. So we removed the stock left behind along the outer edge of our container. Okay, but now we need to remove the stock that was left behind along the inner walls of our container. So to do that, let's go ahead now and select 2D contour again, and we're going to use the same feeds and speeds as we used before, the same tool. Okay, coolant should be disabled, 3,000 RPMs, and a cutting feed rate of 20. Okay, now let's come over to our geometry tab. Now this is important. So we're going to select this guy right here. We're going to come down, select that guy. Okay, and then we're going to select this guy. Now we got to click on that red arrow, and that will move our toolpath along the outside of our circle. If not, it's going to cut away and remove this stuff, and we don't want that. We want our tool along the outside. So we're going to click there, and now our tool will come along the outer perimeter of this feature here. Okay. Our heights are good. Our passes tab, everything is fine. Let's just check smoothing. And now I'm going to go ahead and hit OK, and I'm going to show you something here. So let's go ahead and hit OK. We're not done with this yet. We're going to come back to it. I just want to show you something. So we're going to hit OK. Okay, and there's our tool path. Now you see this right here? I don't like that. That takes up too much time. Because if you simulate it here, watch. It's going to come up and then back down. That's not necessary. So let's close this guy. Let's come back to our 2D contour and edit this. Okay, let's go to linking now, and we're going to check keep tool down and hit OK. And now let's watch this thing run again and see what happens. Notice it doesn't go up now. It stays down, just like it says, keep the tool down, right? Okay, so I'm going to go ahead and close that. Okay, and now it's time to make the feature right down the middle of our part here, this slot here, and that's where we're going to put our acrylic sign. It's going to slide right into here. Okay, and so to make the slot, you probably guessed we're going to use, well, 2D slot operation. Okay, and you probably also figured out that our 3/8 end mill tool is not going to fit in that slot, so we need to change our tool. Okay, so we're going to come on over to Sign Award Tool Library, and we're going to select our 1/8 2 flute end mill here. So let's go ahead and select that guy. Make sure your coolant is disabled. We're going to use a spindle speed of 5,000, a ramp spindle speed of 5,000, and we're going to set all of our feed rates now to 30. Hit the tab button. Just going to set them all to 30. Okay, and now for our geometry, we're going to come on over and we're going to select that guy right there. Okay, basically the slot. All right, and then for our heights tab, we're gonna send our tool down just a little deeper than the bottom of our part. So we're going to go to model bottom, and we're going to offset it minus 0.01 inches. Okay, so it goes, like I said, just a little bit deeper than the part. And you'll see why when we go to face off the material along the bottom of our part later, it'll make for a nice clean separation. Okay. All right, so for passes, okay, our default values are fine. For linking, we're going to change our ramp angle now to 3 degrees. We're going to set our maximum ramping step down now to 0.75 and a ramp clearance height of 0.1. Everything else looks good. Okay, when we go to do this now, pay careful attention to the toolpath. So let's go ahead and hit OK. And if you notice, the toolpath is going to come down and create the slot, and it also will remove this guy, right? This half of our circle here. If you simulate it, you'll like, well, hey, it made half the circle, but it didn't make the other half. So in order to do that, all right, we're going to have to do one more operation to get the other side of the circle. On this side, right here, we're going to have to do a 2D operation, and that's a bore. Okay, so our last operation for this setup, let's go ahead now and select a 2D bore. We're going to use the same tool, a 1/8 end mill. Our coolant is disabled. 5,000 RPMs is good. Okay, and we also can use a feed rate now. Since a lot of this material has already been removed, at least half of it, we can use a more aggressive feed rate. And let's just go with 50 here. Okay, and we're going to use a ramp and a plunge of that 50 inches per minute as well. Okay. And now for your geometry tool, we're just going to select, well, part of that circle we want to remove. Okay, so we're going to click that guy. For our heights tab, we're going to do the same thing we did last time. We're going to send it to the model bottom, but we're also going to offset it a minus 0.01 inches, so it goes slightly deeper than our part. Okay. All of our other settings for now, our default settings, are fine. Okay, let's go ahead now and select OK. And now I'm going to zoom in here, and if you zoom in, you can see this sort of corkscrew toolpath pattern coming down through to create that hole. Okay, so once we have created the slot in this hole, okay, we're good. We are pretty much done. But a couple important things to note. All right, so remember, when we designed this thing, we designed it with these sharp corners, okay, 90-degree corners. Our tool cannot get that. Our 1/8 tool cannot create that feature. Okay, we can send in more precise tools if we really wanted to, much more smaller tools, but we're not going to bother with it. Our part will function just fine. And remember, we need to bore out this hole here because when we go to make our sign, we're going to put a little LED light that's going to, we're going to push it right into this hole, okay? And that's going to light up our sign, and it's going to look pretty cool. All right, so that is it. What I want you to do now is to make sure that everything looks good. So when you go to simulate, I want you to simulate your first setup, go to simulate, and I want you to check out the entire operation duration. So we're looking at around 6 minutes and 11 seconds. So you should have something exactly like that, if not extremely, extremely close to that. Okay. If you have something much shorter or much longer, then double check. Okay. But please run your entire simulation, check for crashes and check for things not looking right. Okay. All right. I'm going to go ahead and hit close. Okay. All right, that'll do it for this first setup. And for the second setup, a lot of the times you'll come on up here and you'll do, well, a new setup. We're not going to do that. Okay, we're going to do our second setup with some soft jaws and a vise. So what we're going to do now is we're going to come on over here, we're going to go to File, New Design, all right, and we're going to save it real quick, and we're going to save it as, we're just going to call it Sign Award Setup 2. Okay, go ahead and save it. Now, you should have downloaded and uploaded this file into Fusion 360. This is the vise with the soft jaws assembled. So what you're going to do now is you're going to right click, okay, once you have it into Fusion 360, and you're going to insert it into the design we just saved and created. Okay, and then we're going to flip it over here. Let's rotate it. Okay, and that looks pretty good. I'm going to go ahead and hit OK. All right, I want to zoom in a bit here. And the next thing we want to do is to right click, and we're going to insert into our current design, okay, our Sign Award base here, and I'm going to kind of move it over, move it up again, and I'm going to rotate it so that it's kind of looks like it's going to fall into place here. Hit OK. And I'm going to zoom in. Okay, and now let's go ahead and assemble this guy into our soft jaws. To do that, we're going to go to Assemble, and we're going to go to Joint, and we're going to make sure we have Rigid selected here. And then we're just going to basically, well, let's think about this now. We got to think about the edges here that are going to match up with one another. So when we go to do an assembly, right, we want to click that guy, and we'll click that guy. Okay, and then we're going to go ahead and hit OK. Okay, and now our part is assembled into the soft jaws here. So recall that we're in design. Now we want to go ahead and manufacture the rest of this part here. So we're going to come on down to manufacture. And as you probably remember, we need to do a new setup. So let's do a new setup. Okay, and obviously we don't want this whole thing. Okay, so let's come on down now, and we're going to select what is it? Our model is going to be that guy, okay? And then we're going to come on over here, and we're going to select selected point, and we're just going to select that guy right there. Okay, but you notice our X, Y, and Z axes are not looking pretty good now. So we need to come back over here, and let's see here. Our work coordinate, well, let's just see if we click on that. Nope, it ain't good. There we go. So it's saying, hey, reference your Z-axis, and our Z-axis, we want it to be something, a line or a feature that goes up and down or vertically. So I'm going to click that guy, and I'm going to flip, I'm going to uncheck that guy, and now that'll send my Z-axis straight up. Okay, but my Y-axis is not right. Okay, we want our Y-axis to be going away from us. So you got to remember we're standing here, and we want our Y-axis to go away from us. So we need to, let's see, we have our X-axis here. So let's go identify our X-axis. And our X-axis is any line that goes left to right. And in this case, this one will do. And now let's go ahead and flip our X-axis, and it should work. There we go. Okay, that looks good. So remember, if you're facing your part in the machine, you need to make sure that your Z is pointing up, your positive Z, your positive Y is going away from you, and your positive X is going to our right. Okay, because we're going to eventually get our G54 work coordinate system off of this hole. Okay, and the last thing we need to do now is identify our stock setup. And if you recall from our previous one, we used a fixed size box. So we're going to do that again, and it was 3.25 inches. Okay, centered, and once again we're going to go with 3.25 inches centered. But if you remember, we did a facing operation, and we removed 0.02 inches of material. So instead of 1 inch now, it's going to be 0.98. So it's a little bit smaller than an inch, and it's not going to be centered. It's going to be offset from minus Z. Okay, 0 inches. Okay, and everything else looks good. Once you've got these settings, go ahead and select OK. All right, so I'm going to quickly just change this to setup 2. Okay, hit enter, and I'm going to go ahead now and start removing the rest of our material for this part. So we want to first go ahead now and face off that material. So we're going to come on up and select a 2D facing operation. We're going to change our tool. We're going to come down to our tool library and we're going to select our 2.5-inch face mill. Go ahead and select that guy. Set our coolant now to disabled. Okay, and if I forgot to do it in any other previous options, they should all be disabled except for that pocket operation that we did in our first setup. Okay, for spindle speeds, we're going to go with 4,000 RPMs and a cutting feed rate of 40. Okay, for our geometry, we're going to select the top of the part. All right, and we're going to come on over now to passes, and we're going to extend out our tool path a distance of 0.75 inches. And we're going to widen our tool path a distance of 0.25 inches. Okay, and we're going to check multiple depths now because we have a lot of material to remove, and we're going to do it in steps or multiple depths as the name implies. And we're going to set the multiple depth value to 0.1. All right, should be good. Let's go ahead now and hit OK. Okay, and so you can see between each of these blue lines is a distance of 0.1, or our multiple step down values here. So once we've removed all of this material, now we need to add the chamfer that goes along the outer perimeter top edge of our part. So let's go ahead and do that. Come on up to 2D, and we're going to select 2D contour. Okay, and we are going to change our tool here. We're going to select in our tool library, we're going to select our chamfer mill here. Okay, it's got that pointed tip. We're going to go ahead and select that guy. We're going to set our coolant to disabled. All right, and we're going to use finishing feeds and speeds here. So we're going to use a spindle speed here of 3,000 and a cutting feed rate here of 20 inches per minute. Okay. In our geometry tab, we're going to select the bottom line here of our chamfer. Okay. And then we're going to come on over here to passes. Everything here is fine. We're just going to set our chamfer tip offset, and we're going to offset it 0.02 inches. And what that's going to do is it's going to move the tip of that pointy tip of our tool just down below our blue line here. Okay, so we don't get any burrs. All right, so we're going to go ahead now and hit OK. And I'm going to zoom in here so you can see, okay, when we go to simulate it, it's going to come down slightly below this edge, our chamfer tip offset here. Okay, so I'll let you go ahead now and simulate that. I'm going to hit close. I'm going to go to my setup now, and let's simulate the whole thing, or let's check out the machining time. So click on your setup 2, come on up to simulate, and now come over to stats, and your total machining time should be roughly 2 minutes and 2 seconds. Okay, if you don't have something like that, please double check your settings. Okay, I'm going to go ahead and hit close. All right, that'll do it for this part. Thank you so much for watching. We'll see you next time.